Today we're going to be talking about adding fractions and mixed numbers. The first thing we're going to do is adding, okay, with like denominators. Sorry, some of my letters didn't connect together, sorry. Okay, what is denominators? The bottom number, okay? So I'm adding fractions that have the same bottom number, the same. When you add, okay, fractions with the same denominator, you're just going to add the top numbers. Okay, so you're going to add the numerators. I'm going to put out here top numbers, so you'll know what that is in case. Okay? And that's going to be over the denominator. You're not going to add that. I'm going to put that out here. Do not add. Okay? And here's an example. If I have 1/3 plus 5/3. First thing you should notice is that these two denominators are the same, right? They're the same. Dante, office, please. Okay? I'm sorry, if they need you, they'll call you to the office. Otherwise, don't worry about why they need everybody else. Because they're the same, you're going to actually add the top. So I'm going to go 1 plus 5 and keep my bottom number the same. Now, you can omit, you can skip this little step. I'm doing it so you see what I'm doing, okay? Now, what is 1 plus 5? And it's 6/3. Now, in this case, what do I know? What is 6/3? It's an improper fraction. So it's 2/1, and what is 2/1? What is 2 divided by 1? 2. So my answer is actually 2. That one actually divided out. And I shouldn't have done that one first, but it's a good practice. Right on the board. Okay? And you may need to leave enough room and come back to it. I can skip back ahead, okay? This right here, you might want to for a step or two, and maybe just put like a little star or something. That's just showing you how I'm doing it. So when you go back to look at it, you'll know how I got 6. Okay, but it's not something you have to write down in every step. Right here? Because, okay, we said 6/3, we reduced down to 2/1. What is 2 divided by 1? It's my whole number, right? And I have nothing left over.
Another way, instead of doing what you get right there, like 1 plus 5 on the thing, where you wrote the fraction down, you can say fractions, like that, right there. So it's easier.
You're right, and I said I'm writing it down so you see where I got it, that you do not have to write it down. Okay? So just pay attention, please. All right, let's look at this one. What if we have 2/8 plus 5/8? First thing you need to do is look at the denominators. They are the same. So I'm just going to add my two top numbers. So again, this is an optional step. But what is 2 plus 5? Can that reduce? So I'm just going to leave it. Okay, we're going to talk about that in a minute. This first section is just dealing with denominators that are the same. Okay? Now, let's look at some mixed numbers. What if I have 2 and 5/6 plus, I really don't want that 5. Let's change that 5 because I don't want him to go over yet. Not for our first one. Let's do 1. And let's do 2 and 3/6. Now, look at your denominators again. I'm not worried about my whole numbers. My whole numbers are 2 and 2. I'm not worried about those. I'm I'm worried about this, still this part of this fraction. And what I notice is my denominators are still what? The same. So when I get over here, okay, I'm going to add my 1 and 3. Alright? What is 1 plus 3? 4. And that's going to be 4 over 6. Now I do have to add my whole numbers as well. So what is 2 plus 2?
4.
So that is 4 and 4/6. Okay, we're going to talk about unlike just in a minute. Right now we're only talking about like denominators. At this point I could reduce that as well. And so if I reduce that, what would that be? 4 and 2/3. What did you reduce that by to get to 2/3, Dylan? So he took this 4/6 and divided it by 2 over 2. And that's where he got 4 and 2/3. Yes, you do need to do that. Okay? So yes, you do need to reduce that. Okay, and we'll skip ahead. We're going to do another one. Let's say I have 3 and 2/3 plus 1 and 2/3. Add my two whole numbers. So what is 3 plus 1?
4.
Are my fractions, do they share the same denominator?
Yes.
So I am able to add the two numerators. So what is 2 plus 2?
4.
And what's the denominator going to be?
3.
Now, what do you notice about this part of the fraction?
Improper.
He's improper. Okay? So how can I make this part, I'm not worried about my 4 yet, how can I make this right here a mixed number? Okay? And so what would I get? If I divide, I'm just going to go over to the side if I can get there. Let's see if I can go down. So 3 into 4, how many times will 3 go into 4, Zach? And 1 times 3 is?
3.
And when I subtract, I get? Okay, so what does this mixed fraction look like?
1 and 1/3.
Does everybody agree that 4/3 would be 1 and 1/3, right? Now, just look, I'm adding that extra 4 back to him, that whole number. So now, what is 4 plus 1? And this fraction, there's nothing for me to do. He just gets tagged along right with it. We're going to do another one or two of those, okay? Okay. Did you understand how we got here? Okay. Well, what I noticed was he's improper. So this is the baker. He's got 4 whole pies, and he has 4 pieces left, and the pie tray only can hold 3 pieces. So what happens? He fills 1 whole pie pan, right? So now he has how many whole pies? He had 4. I just filled 1 more, so that now makes me have, and he has 1 piece left. So that's where he has 5 and 1/3. Okay? Right? No. Okay? We're just adding right now. We're not doing anything with that. That's the answer. Okay, so let's look at another one. I want you guys to try this one. So take just about 30 seconds to try this one, and we're going to talk about him together then, okay? Now, I know this one's improper right here, but he's okay. Go ahead and add before you deal with him. Okay? Add before you go ahead and deal with him. All right, Brianna, what'd you get? 7 and 3/5. Okay. All right, let's look. We're We're going to add our whole numbers. So what's 6 plus 1? 7. When I look at my fractions, okay, my bottom number is the same, my denominator, so I'm going to add the top. So what's 2 plus 6? And that would be over 5, right? Now, 8 over 5 is improper, correct? So let's deal with him. 8 over 5 would look like what as a mixed number? 1 and 3 over 5. Because if I took 5 into 8, it went 1 time. 1 times 5 is 5. And when I subtract, I get 3. Okay? Now, if that maker has 1 and 3/5 plus his 7, how many total does he have? 8 and 3/5. I think you just forgot to add that whole number to it, okay? You changed everything else right, we just got to add that whole number back in there as well. Okay? Let's look at another one. Let's do one more, and then we're going to kind of move on. Okay? Let's say we have 2 and 4/3 and 3 and 1/3. Add that very quickly. All right, I'm going to let Griffin answer this one. Okay, Griffin, what do you got? Okay, now, am I done? So what am I going to get now? So let's change this. 5/3, Griffin, would be what is a mixed number? So what's here though? Okay. Alright, so if I'm taking this and adding it back to every how many whole ones I have, what's my total? I'm taking this and adding it back to this part. 6 2/3. Okay? Okay, how many of you got this part right? Okay, how many of you got this part right? Okay, okay, let me ask a question. How many of you took your 5/3 and went over here to the side and got that part? Did you get that part right? The ones that didn't, did you just not know what to do, or did you just divide wrong?
I don't know what to do.
Okay. All right. So once we get here to the 5 and 5/3, I'm going to erase all this for a minute. You notice he's improper, so I've got to deal with that improper part of the fraction. So I'm going to take him out of the picture for a minute. And I'm going to go over to the, I'm going to the right on my paper, but I don't have enough right on my paper space. So I'm just going to go down here. 5/3. He's improper, so I need to force him to be mixed. We did this last night. So I'm going to take 3 and divide it into 5. And we said 3 will go into 5 1 times. 1 times 3 is 3. Subtract and you get 2. So my mixed number is 1 and 2/3. Okay? Now, this 1 and 2/3 is going to replace this little piece right here. They're the same thing. Alright? But now what I've got to do is I've got to add this back to this whole number. So all you're really doing is adding the two whole numbers together. Your fraction doesn't change anymore. So 5 plus 1 is 6, and my fraction stays the same. Okay, let's do one more of those. let's say I have 4 3/4, and I'm going to add 1 2/4 to that. Okay, we're going to let Logan answer this one. Let's give them just a second or two longer, okay? When that hits 15:45 at the top, okay, I want you to go ahead and tell me what your answer is, Logan. Okay, it's 5 and what? What's your final answer? Oh, okay. All right. Well, what did you get here then? 5 5/4. Okay. And now what am I going to get? If I take 5/4 over here, what is he as a mixed number? One times 4 is? Subtract, you get? Okay, so what's my mixed number look like? Did you say 1? Okay. Yep. Okay, so I'm going to take this, and I'm adding back to this whole number, so he's going to be what? Take this whole number and add him to that one. 6 and... Okay, 6 1/4. Okay? Yes, JD. Right here, because I'm changing him from improper to a mixed. And this is what we did last night. Okay, so you're going to take your 5 and divide it by 4. So 4 is what the number is dividing by. So 4 has to be up front. Okay, so that's why I'm going 4 into 5. Alright, now we're moving on. Now we're going to add fractions with unlike denominators. Okay, so unlike denominators means your bottom numbers are not the same, correct? Alright, so we're going to get things like 2/3 plus 1/4. Okay, so that's what we're maneuvering now. Now, there's different ways to do this. Okay, I'm going to show you the way that I feel is the easiest. That doesn't mean it necessarily would be the easiest for you. And I'm not going to talk about every different way we can do it. Okay? We need to get a denominator where they share something in common. So they have to be the same number on the bottom. And at some point, then I'm going to reduce. Okay? Now, what I suggest you do is you take and multiply this by this bottom number over here. So you're going to multiply 2/3 by 4/4. Now I'm going to write it out so you can see what I'm doing. Now what is 4/4? 1 whole. And anytime I multiply anything by 1, does that number change? No. So I'm making him look the same by multiplying him by 4/4 because that is 1. Now, I'm adding. Now, for this one, what do you think I'm going to end up multiplying by? 3. The opposite number. So I'm going to multiply by 3/3. Now, we're going to multiply these. What's 2 times 4? And what's 3 times 4? Now, what's 1 times 3? And what's 4 times 3? Now, I forced those bottom numbers to be what? The same. Now we're going back to what we just did, which we know we do what to the two top numbers? add them. So what's 8 plus 3? So it's 11 over 12. Yes, Brianna. Yes. Okay. Now in this case, the least common denominator is 12. Okay. Now sometimes, and we'll do one where we can do it both ways. Okay. So let's look at, let's say we have 1/2, and we're going to add them to 1. Let's say 1/4. Okay? Now, we're going to do it my way first, and then we'll go back and do it the one finding the least common denominator, okay? If you do my way, you're going to take 1/2 and multiply by what?
4.
By 4. So we're going to do 4 over 4. And I'm just bringing my add down. I'm bringing 1/4 down, and he's going to be multiplied by 2 over 2. And that's the opposite number. Okay, that number is what's guiding what I'm multiplying the opposite one by. Okay? So 1 times 4 is? 2 times 4 is? What's 1 times 2? And 4 times 2?
8.
So now my denominators are alike, correct? So at your top, what's 4 plus 2?
6.
Now, this is where you need to come in and reduce. You need to reduce that fraction. How can I reduce it by? 2. So that would be 3 what? What's 8 divided by 2? 4. Okay? Everybody see what I did on that one? Now, what Brianna was asking me earlier, it was using the greatest common denominator. Oops, sorry. And some of you guys will be able to do this method, whereas some of you can't yet. And it's okay. They're both going to come out the same. If I look at these two bottom numbers, 2 and 4. Let's count up my 2's. 2,
4, 6, 8, 10, 12, 14.
okay, I'm going to stop right there because he's going to keep going forever, right? Hopefully I found a number small enough. What about 4? 4, 8, 12, 16. Okay, you want to see if it's long? Do you want it? Well, no, I just said hey. Yeah. Do you want her number to call her real quick?
I'll call her.
Okay.
Or after this class.
Hang on 1 second, guys. Alright. So, when we're looking at the greatest common denominator, what is the smallest number they have in common, Zach? 4. Does everybody see that? No, I can keep going higher. Remember, those keep going. Okay, this is going to be the highest that I've written down, but they keep going forever and ever. But right now, the smallest one is 4, right? So, we want to forcibly make 1/2 become a 4 on the bottom. So what would I have to multiply by on the bottom to make him become a 4? 2, because 2 times 2 is 4, right? Well, if I multiply the bottom by 2, what do I have to multiply the top by? 2.
2 over 2.
Why? Because 2 over 2 is 1 whole. Okay? Now, does this one need to be changed? Because I wanted it to be a 4. So does he need to change? So I can keep him the same. And I'm not going to multiply him by anything. Now, I'm going to multiply this. What's 1 times 2?
2.
And 2 times 2?
4. So 3.
And I'm just going to bring my 1/4 down. Now they are like denominators. So I'm just going to add my top numbers. So 2 plus 1 is 3 over 4. Okay? Now, It's hard just to think about what your, actually it's the least common denominator is really what I want to say, not greatest. Okay? Alright? The least common denominator. Alright? But this one you don't really have to think about until you have to start and reduce. Okay? It's a little bit more work, but we don't have to think outside the box as much. Alright, let's look at another one. Let's do 3/5 plus 1/2. Do that quickly. You got about 30 seconds. Either method. Either method is fine. Alright, Dylan. What are you going to end up multiplying 3/5 by? So 2. What am I going to multiply 1/2 by? Okay, so what did you get here, Dylan, when you multiplied? Okay. And what do you get here when you multiply? 5, because 5 times 1. Okay. Now what do you get when you add? Now, do I need to leave it like that? So what's my answer? How many times will this go into that? 1. And how many would be left over? 1 and 1/10. Okay? Alright. Okay, hush. You're going to take your 3/5 and you're going to multiply him by whatever this bottom number is. So that's where the 2 came from. Okay? You got to multiply both top and bottom. You're still going to add. You're going to take the second fraction, and now you're going to multiply it by whatever the opposite bottom number was. So this case was 5. So now you're just going to multiply. So 3 times 2 is 6. 5 times 2 is 10. If you would quit looking at Lily and talking to her, you might understand. 1 times 5 is 5. 2 times 5 is 10. Now we have denominators that are the same, and we're going to add the 2 top numbers. So 6 plus 5 is 11 over 10. Now we're back to what we did last night. And if you need to go over and divide, I kind of just talked you through finding their numbers, but you can always go over and divide. Whole number, and then here's your fraction. Hush. Now let's do one with a mixed number. Say we have 3 1/3, and we have 2 1/2. Your whole numbers are going to stay whole the same the whole time. When we go to multiply in a minute, it's only your fraction that gets multiplied. Okay? Not your whole number. Well, you have to bring in and get a common denominator. Okay? Now, so when I take my 3 over here, he stays whole number. This 1/3 is what I'm going to multiply, and I'm going to multiply it by the opposite fraction's bottom number. So I'm going to multiply it by what? 2. Now, plus 2, and I'm going to multiply 1/2 by what? 3. I mean, I got to keep them. I'm just not going to multiply them. I got to keep them there. If I lose them, then I lose my problem. Now, so when you do this, you're only focused on multiplying this part right here right now. So 3 stays the same. What's 1 times 2? And 3 times 2 plus whole number of 2. And what's 1 times 3?
6.
And 2 times 3?
6.
Now I notice my denominators are the same. So I'm going to go back to doing what we did a minute ago. Add your 2 whole numbers. So what's 3 plus 2? And add your fraction. So what's 2 plus 3? And your bottom number stays the same. Okay? Alright, stop right there so you guys can work on your in-class assignment to turn in.